Okay, now this example here, we are going to investigate two cases. The case of dropping a ball from a certain height to a certain height, and then in the other part, we are going to toss it up from this height to the same height. Now, in the case when we drop the ball, we are asked to find the work done by gravity. Work done by the gravitational force is Fg times the displacement. That's the definition of work, F times displacement. Now in this case, Fg and d are pointing in the same direction. Okay? So if my displacement is negative, but my Fg is also negative, and both of them are pointing in the same direction. So that means my work is going to be just, I can either write them both negative or just the magnitude of Fg times the magnitude of d, which is going to be, what's the magnitude of Fg? Let's calculate it here on the side. Fg is m times g. M is given to be 5 kilograms times 10 meters per second squared. So that gives us 50 newtons. So we are going to end up with 50 newtons here times 20 meters. So that gives us 50 times 20, that's 1,000 joules. So that's the work due to Fg for part 1. Now in part 2, we don't care how we did that, but when the ball is going from here to here, now my displacement in this case is plus 20 meters. However, my Fg is still negative, still in the same direction, and it's still 50 newtons, which means the work due to Fg in that case is going to be minus 50 newtons times 20 meters, which means it is minus 1,000 joules. So in the first case, the gravitational force added energy to the mass. This is the plus 1,000 joules. Now, in the second case, the gravitational force took away energy from the mass. That's why we have minus 1,000 joules. Okay, that's the main difference. Okay, we'll stop with this one here. We have we have another example coming.